So in this video, we're going to talk about evaporator coils and what happens when ice forms on these coils. So on the outdoor unit on a heat pump system, it's normal for ice and frost to form on the outdoor coil because heat pumps operate in temperatures below freezing, and so any moisture that collects on the outdoor unit will of course freeze. That's why a heat pump has a defrost mode to clear this ice that forms on the outdoor unit. But when we're talking about indoor coils, this is not normal. And usually the only way to clear this type of ice formation on an indoor coil is if it is a heat pump, you could reverse cycle and try to clear it that way. Otherwise, you just have to wait until the coil thaws itself out before you can determine what's going on. Now in this case, it's pretty clear what is happening here. You'll notice that the insulation on the one side of this coil has come loose and has been pulled up against the coil. So it is restricting the airflow through the coil, causing the ice to form because there's not enough airflow across the coil to transfer the heat. Due to the amount of ice, I'd say there's probably something else going on, but definitely you'd have to start with getting the insulation off the coil and restoring full airflow across this coil. So whenever you see an indoor coil frozen up like this, the first thing that would come to mind is airflow. And of course, every technician tells us that the airflow is good and there's no problem there, which we'll talk about in just a minute. The other thing is refrigerant flow, which if it's low on refrigerant or there's something wrong with the charge, could also cause a problem like this. So the most prominent reasons for an evaporator freezing is, of course, airflow. And we always talk about airflow in all of our videos because I'd say probably 95 to 98% of the time the phone calls that we get in tech support have to do with airflow. You just don't have the airflow across the coil to maintain proper heat transfer. So airflow is the first thing that you want to double check. And you'll notice that the next two, dirty filters and dirty coils, also relate to airflow. If the filter is plugged, you're not going to be able to get the airflow across the coil. And if the coil itself is dirty, that will restrict the airflow going across the coil and transferring heat. So airflow is a very important thing to look at. Then next, as we stated, refrigerant problems. If the system has a leak or if there's a problem with the charge, there could be a problem with a refrigerant issue. And then the outdoor ambient being too low or low indoor load. This would cause the coil not to be able to transfer the proper heat, and so therefore all ice and frost may build up on the face of the coil. And then lastly, a clogged condensate drain. You don't see this very often, but if the water on the coil, the condensate, is allowed to back up and collect, it could cause a problem if the coil is near freezing temperature. So in the evaporator coil, as the refrigerant is metered through the TXV, there is a pressure drop and a temperature drop. So the refrigerant coming into the coil is cold at that point, and as it progresses through the evaporator, it's picking up the heat from inside the structure, and by the time we get to the end of the coil, the refrigerant has increased in its temperature. In order to do this, there needs to be the proper charge flowing through the coil to do the work throughout the entire coil, and there must be proper airflow across the coil in order to ensure the transfer of heat in the coil itself. So you may get tired of me emphasizing airflow, but I'll tell you again that 95 or more % of our calls that we get in tech support have to do with airflow. And even though the technician may say, oh, yeah, I have the proper airflow, he really doesn't. And one of the ways that you can determine whether you have proper airflow through a coil is by taking a traverse on either the round or the square duct areas. So this is taking a grid type approach to the ductwork and taking readings to make sure that you have the velocity that you need through the entire duct and that there's not some turbulence taking place inside the ductwork that is restricting airflow over part of the coil. So it is my professional opinion that every technician working in HVAC should have some type of manometer. The most common type today is the digital manometer, and you should have one with the proper tubing, the T's, and the pitot tubes to take readings in a ductwork. If you've checked the entire system and made sure that all the registers are open and free, and that there is proper design of ductwork, the only way to determine whether you have complete airflow across a coil is by taking a traverse reading with a digital manometer. So next time you're scratching your head on a job and can't figure out why an evaporator coil is freezing, get out your manometer, punch a few holes in the ductwork, and find out where your turbulence is, and then fix it.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.